hiatus from coding. I just like was playing video games and such. But now I start up a new plugin, uh, or I'm about to, for Parallax Motion, which we can use to basically simulate larger spaces than we're able to actually generate. So I think this was the one I used, and this will be Parallax Motion. See if it works. Don't put well. Okay, I see. So plugins, add, cannot be named the same. We'll call this Parallax Root. So yeah, the idea of this is we want to build an object that we can use as a root that we can attach other things to that will handle parallax motion for us, which is the idea of like if I wanted something that was like a size 10 to feel like a size 20, but I could only represent a size 10, then when I, for instance, when I move towards it and I move 10 units towards it, if it moved 5 units away from me along the same vector, then it would feel like it's twice as far away as it actually is. And that's like the long story short of it. Ooh, 5, 6. I want to move to 5.6, but a lot of my plugins need 5.4. So, okay, so we can start this up because I think most of this we can do with the blueprint. But yeah, the idea is that like I want to be able to have a star system that's say 100 billion units in scale, which would be centimeter to meters 100, so a billion meters is like a million kilometers, which is not that big. But I want it to be like the size of the universe. Well, with the right settings on a parallax motion wrapper, we can make that thing that's only a million kilometers across actually fucking like move with the character so that it feels much bigger. All right, so we just wait on this shit to build, and then we're gonna immediately start on an actor for this. So the idea here being we create an actor that handles the movement, and then we can attach whatever we want to that actor as a child, and just let the top level actor handle the parallax movement, and then we can use it on large objects or particle systems or whatever we want. All right, come on. Being quite slow. All right, come on. Build up. And this slow ass son of a bitch. Come on, come on. Build, please. Oh. Uh, okay, we gotta take that out. Alright, so hang on a second. We want to get rid of that. Plugins, parallax root, source, third party. Get rid of this. Alright. So we have a content folder here. It's an actor. BP parallax root. Alright, so we're going to need a few things here. We need um, actual scale. Virtual scale. Parallax factor. Hmm. Parallax coefficient. Speed coefficient. Okay. Start this as a default of 100 billion. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That's a trillion. 100 trillion. And let's make this smaller actually. For our default, this would be like scales that I would expect for doing like a galaxy or something, but 1, 2, 3, 4, 5, 6. We'll do 1 million to 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1 million to 1 trillion. And then okay, so this can just be default of 1. This is computed internally. Okay, so actual scale, virtual scale. Divide the actual scale by the virtual scale. And that gets our parallax factor. Um, and I think this is actually supposed to be -1. Correct. So let's think about this. So if I wanted to be twice as big, then this would be 2x this in scale. So this is going to come out as 0.5, and this is going to yield 0.5. And then we're going to need frame movement frame of reference movement delta. This can be vector. This is also derivative. And then we're going to want last frame frame position or movement delta. Last for position. Alright, for position. Let's move the frame of reference acronym out to the front so that stuff can stay together. Alright, so what do we do? What do we do? What do we do? So the first thing we gotta do is we want to get okay, so begin play. I'm going to set both of these on begin play. For now, we'll just do player 0. It's just single player for the moment. Camera location. And we just do this. I could actually just do it like this, make it a little bit cleaner looking. Alright, so this initializes our frame of reference positions when the game starts. On the on the tick, we're gonna want to set the current position. The first thing we do is we set the current camera position, and then we're gonna set the movement delta. And that's gonna be this minus this, and that becomes our movement delta. Um, this is also something we can do. We can multiply, um, and multiply this by the speed coefficient. Put it here. Okay, so this is our calculation to set the parallax factor. So now we have our movement delta. We might as well just, I guess, set everything. Set this. After we've calculated our delta, we don't need this last position anymore. So it gets set to the updated position. Okay. So I think by this point we should have all the calculations we need. We have our scaling factor, parallax scaling factor, our speed coefficient. We have our current position and our movement delta. Self. Get world location. All right. We can just do this. Make it a little bit cleaner. So we need the world location for this. We'll do one more vector. We'll call this the parallax update vector. So the last thing that we need to do is set this, and this should be equal to movement delta multiply by the parallax factor. All right, this is the position update, which means that we'll need to add it to this. And finally, set world location to this. Teleport. So I think that might be it. So we only need to expose three things here: an actual scale, a virtual scale, and a speed coefficient. Then we should now be able to add one of these to our scene. And reset this to 0. And let's delete this stuff. So now let's attach our chamfer cubes to it. Alright, so now, is it going to work on simulate mode? No. Turn gravity off. Okay, it's not working like that. Delete all this shit. Make this big. Why can't I move? Okay, it's not working. Doesn't appear to be working. Okay, great. Um, I'm gonna add just a single cube to the 0, 0, 0 location here so that we can see the root. delete this. What? What the? Okay, so we gotta make this smaller because I'm not sure if. I don't understand what's going on with this. Okay. Something is mega screwed up there. Let's delete. Interesting. So that works fine. Then we're gonna add back in the parallax movement actor. Put it here. Okay, we're doing something with the camera we shouldn't be. Save everything. Let's see. I don't understand what I'm doing wrong here. I'm gonna go to coworker here in a moment. I just something's up here. Toggle a breakpoint here. Hitting any breakpoints? What? What the fuck is going on here? What? Extremely confusing. So, at this. Print out the update vector. Wait, what are those numbers? Let's do this. If length greater than 0, branch. So maybe our calculation here is off. Hmm. Bum, 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 bum. Let's try something a little different here. Seems to be working a little better. Let's do 4x. And let's get one of these guys and kind of put it adjacent to where this thing starts at. Alright, that's close enough to probably get a feel for this. And we'll go over here and start and run towards it. Okay. Let's try and increase it some more. Let's do 10x. So it should take 10 times as long. Okay, maybe not based on on camera, but the character position. Um, Player world location. It's not doing anything anymore, so that's not right. Should it be something? Something feels off. So I'm trying to figure out. Let's run it by the. Let's run it by a coworker. Okay, gonna ban this guy real quick. Okay, so Let's go here. Okay. Here is my first shot at a blueprint implementation of Parallax rolling. I'm not sure it's correct. Take a look. Okay, let's try this again. We're just gonna stick these on the root. Alright, so if this is 1 to 1, everything just moves 1 to 1. Seems fine. If this is 30 to 1, yeah, let's turn collision off for this. Why am I all of a sudden hitting breakpoints now?
It sort of works, but it's not right. Um, there is still something with it with a higher ratio. Um, it changes the starting location of the actor. Starting the actor should start in its version and already it's Parallax actor's location set the initial actor. Yeah, but wouldn't that have a problem and make it to a version rebasing later? Attractive part of frame by frame accumulation. I thought the numbers would remain relatively small and as should be unaffected by precision issues of rebasing. So he's saying is initialized boolean file. This should default to false. Oops, no, don't delete this. Default value false. Okay, and then we can just do branch.
And then we can probably get rid of this. It's hard to tell for sure. Alright, then parallax root. Yeah, it's no longer having an effect. Oh, I'm a dingus. I'm a big dingus, a really big dingus. I'm a big dingus. Yeah, we need to set this. Okay, now let's try that. All right, now try 20x. It's definitely doing the thing, but it's like this positioning shit is not right. Okay. Like you can see that it's doing the thing it's supposed to be doing, which is like basically making this behave like it's further away and bigger than it actually is. Um, and these are not going to be like interactable things in the scene. They're going to be things that are very large, like stars in a galaxy, galaxies in a universe. However, so if I start this again and I go and I select that root object here. Yeah, so like at the very start, it has like drastically shifted the location of it.
my god. Yeah, that would do it. That would cause an issue. Alright, so let's go over here. God damn it. Um, should we maybe use the player location instead of the camera locations? The ADC does not change that. What's that? Or should that take into okay. So how I find player position in blueprint. Oh my god. Bullshit. Uh get player zero world position UE5. Easiest get player controller, get controlled pawn, get actual location. Okay. Player controller, controlled pawn, get actor location. Great. Change this out here. I think that's the only place we use it. Okay. Let's cut this down to just a 2x. That fixes the initial location. And now it's working exactly like I thought it should. Like as we get closer to it, it gets further away. It takes us twice the distance that it started at to actually get to it. Okay. All right, that cracks it. Okay, so that's really cool actually. So here's our parallax route. We can delete the begin play because we're gonna do it this way. We're gonna clean this up a bit. Do 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 do. So what we could actually do is, since this always gets set no matter what, do this first. Yeah. Get rid of this false thing here. Teddy, shut up, you fool. You silly pup. You silly puppy fool. No, they barking out there. I gotta bark at them. I gotta let them know I'm big and tough from inside my house, and they better not come in here because I don't know what I'd do in that scenario. I'd probably put my tail between my legs. All right, there we go. Yeah, we no longer need this first set. It's always gonna be set. Huh? Change it for a get. Hook these in here. Delete this. Okay. Now we're talking. Now we're talking. Okay, so this appears to fix that, but it's not applying to objects that have been attached to it. So, like, that we've got to figure out. And what we can actually do is we can um, take this, set it to 0 so that it's dead center, and then drop it just a smidgen so that's under all these cube objects. And then if I spawn in on like the far edge here, I should reach it by about the time I reach the other far edge. Thus illustrating the principle. And it just like it behaves. Yes. Okay. Awesome. Well, this didn't take as long as I feared. This was actually pretty quick. So what can we do with this? Well, the main thing that I want to do with this is to attach very large particle systems to it that will take the place of showing like stars, external stars and galaxies. So I don't have enough space to render a galaxy scale particle system with precision, except when you're like really close to the origin of the particle system. But if I rendered a particle system that was like maybe 1 billion units wide, would apply a virtual scale to it, then we can have precision and like proper motion, proper sense of scale. But for that to work, this root has to work the way we want it to. We want these chamfer cubes that are inside of this. Um, Detach. Uh, okay. I have actors attached to another actor, but when the parent actor moves, the do not. Mm, Damn you, Gemini. Um, okay, I have an actor set up in UE5 that controls parallax movement. The idea is being able to attach other actors in the scene to it as children so that they will also get the parallax movement. Currently, I have attached few cubes to it, but while the parallax root does move as expected, the attached actors are not being affected by action of the actor. Turn this off, turn this off, turn this off. Okay. Oopsie. Oopsie poopsie. Okay, so back over here. So I'm gonna go like right here, maybe. Start it up. That seems to be working. Yeah, so we catch up to the we catch up to the unattached at about double. Hell yeah! All right, this is super cool, super duper nifty. So let's try some more stuff. What if it was instead of 2 times? What if it was 20 times? All right, very cool. So now, let me think. We want to attach like a point cloud to it. I think this is mislabeled too. So what would be 1 over 20? 0.05? So we can actually also just speed it up. The whole idea, like another thing that I want to be able to do is like change frame of reference for like movement. Like for instance, unload the current star system and begin moving towards and then begin like interstellar travel where we can like increase the speed at which you move through this. So that's why we have the third coefficient here. Um, we'll leave it at 1 for now. Let's go ahead and go over this. This this is a really easy actor. We can actually delete this cube out of it now. Okay, so to make this parallax actor, if anybody was interested in doing something similar to what I'm doing here, is actually very easy. Are those literally, they're literally at the same spot. Move these back. It's about here. Delete these. Move those here. Move this back. And we can do something like move this forward a smidge now. Okay, movement delta is here. Update vector here. I'm just gonna quickly go over what the blueprint ended up being in case anybody wants to follow along. Okay, so we have a number of variables. Actual scale. This should be the scale of whatever object you're attaching to this. Um, so if I wanted some, like if I made a point cloud and it was 10,000 units across, but I wanted it to behave as if it was 10 trillion units across, then my actual scale here would be 10,000 and my virtual scale would be 10 trillion. Um, Parallax factor, we'll do this as so parallax factor is a float and it's not exposed. Speed coefficient, I'm going to change the name of this. I'm just trying to think of what. Uh, effect coefficient. So, okay, parallax factor, this is the actual ratio that is calculated to apply some portion of the player's movement to this stuff. Effect coefficient. Effect coefficient is going to be our um, secondary coefficient that can be used to do things like speed up arbitrarily how fast you scroll through the thing. Movement delta. This is the frame of reference movement delta from the previous frame. Frame of reference last position, frame of reference current position. Parallax update vector is initialized as a boolean. So the first thing we're gonna do is get the player location here. We each frame we set the frame of reference current position to the actor's location. We check if we're initialized. If we are not, then we're gonna set the frame of reference last position equal to the frame of reference current position. Flip is initialized to true. Then we'll catch it on the next frame. Next frame comes around. Now we have current position set, last position set. We come in here. We subtract the last position from the current position and we set the frame of reference movement delta. Then we set the last position because we this is what we need out of that. Then we're going to calculate the parallax factor, which is going to be the actual scale divided by the 1 minus the actual scale divided by the virtual scale times the effect coefficient. We set the parallax factor, and then we multiply the movement delta by that factor to get the parallax update vector. Then we add that update vector to the actor's current position and set the actor's location as a new position. Um, so that is it. It's pretty simple for this part of it. And then if we just and we can see like this is behaving like it was much larger and very very far away because it's taking me a long time to reach it. And in fact, I cannot reach it. It's too far away. And that's because I think we moved it up to something ridiculous because we were testing. Yeah, it was like 1 to 20. We try to reach these objects, but we simply can't do it. They're too far away. Um, let's try dropping in a little bit closer to them. Yep, alright, seems to work. Okay, so now we want to attach something to it that can kind of show it off a little bit better. Oh, and the other question, is this ever going to work with simulation? No. Um, UE5 get simulation mode camera blueprint. Simulation mode player position. Yeah, okay, this is what I've done before. Viewport camera location, perhaps? We may need C++ for that. think we can skip it for the moment. I am working in UE5. I just set up a motion actor. I would like to set up a particle system attach to it for test purposes. Just a simple random distribution static point cloud like list. Fine. Teddy, 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 Teddy. At you on your stupid little head. Oh, yo. I can feel the nap coming on, yo. What's up, dude? We doing some cool shit here. We got the. I kind of got the thing that I was trying to do working. It's not like crazy impressive at the moment, but it can be used to represent like a star system that's a lot larger than the game world can actually handle. And what it basically done is made this like parallax can't talk parallax root component that you can attach things to. So in this case, you can see that these two cubes are attached to it. This one's not. So, and then if I go and I look at this root, I have an actual scale here and a virtual scale. Right now I have it 10x. So what that it means in practice is that as I move towards these two objects that are a child of the parallax root, it will take me 10 times as far as it looks to get to them. So like if you look at this one, it's not attached. So I'm gonna go ahead and hop in. Actually, I gotta switch it off of simulate mode. Yeah, like this. Um, so to get to this one, I just run one to one. But the ones that are attached to the parallax motion object, I would have to run 10 times as far as their perceived distance to get to them. Um, and that's because like they're moving along with me by some percentage of how far I'm moving. So like if I made it a little bit more obvious and take it down to like a 2x and drop in like that. So now to get to these I have to run twice as far. So like I can still get to them now, but I have to run substantially further. And the whole idea of this is that I want to represent like universe and galaxy scale systems. Um, and you just like you literally can't get the level of precision needed in Unreal to be able to like for the particles to not be jittering around when you scale them that large. But if I say made my particle system, I don't know, let's say 1, 2, 3, 4, 5, 6, 7, 8, 9, 100 billion units. So that would be like 1 million kilometers or something like that is the actual size of the particle system, and it'd be able to maintain precision at that scale. But then I wanted it to be like a galaxy-sized object, so we went with like I don't know something like that. Then when you move through that particle system, you would have to move like the actual galactic distance to cover that space. But we also have this effect coefficient, which we can use to basically cheat and travel at a different velocity than the scale of the thing. So like if I'm moving around inside a star system coordinates and I'm like actually interacting with game world objects, I could keep this at a 1. But if I wanted to say move at like interstellar scales, then I could reduce this to some fraction, clear out the scene root of like all the local space stuff, and move in between them. And you could do all this like in real time without having to do any loading or anything like that. But like here, if I start here, I will like never even be able to come close to getting to these objects because they're moving almost 1 to 1 with my character. Like you can see the two cubes off there in the distance that we haven't really closed the gap at all. And that's because to get to these, I would have to travel like a million kilometers or some shit like that. Um, so like taking it, and it doesn't really matter. What's important is the like ratio here. So like if this is gonna be 100,000, then if I change it to 300,000, it'll be treated as if it's 3 times as large from like a movement perspective as it actually is. So like I have to run 3 times as far to get to it as it would look. And like this system is all for things that are like way bigger than like the game environment would be. Yeah, exactly. And it's like you wouldn't use this for like planet scale objects because I could represent those just in the engine. This is the idea of like I've done some work in some other projects for this as well with like data models and things like that. But the idea is that I can procedurally generate like a universe level particle system of galaxies, and then each galaxy, as you get close enough to it, can generate a galaxy scaled like data model of star systems. And then like those things, like the stars in a galaxy and the galaxies in the universe, those all need to be like moving in a smaller particle system than the actual thing is, but they need to behave as if they're really large. And so like that's kind of the whole idea of this object is to give a wrapper to that you can just attach anything to and it'll get this like parallax movement behavior. So next up, I think I was going to go ahead and try to spin up a particle system just to see what that would look like. So let's find something here. G test system. All right, perfect. And then we can just set this back to 0, and then we'll take this and we'll parent it to the parallax root object. And now if it's working, which I don't know if it is, hard to say, actually, if this is working or not. Let's go into the system here and make it not moving. How big is this fucking particle system? All right, so let's just do, I don't know, like 100. Okay, it's not working yet. These are still moving too quickly. I can just tell. So physics, simulate, oh, touch. Um, Something about how I've attached this is wrong, probably. Yeah, maybe it's well, it's actually we should be able to tell, right? If I move it. Okay, yeah, yeah. It's doing its particles in world space is what it looks like actually. So I think you're right. So we'll delete this. Um I think you are correct, sir. And let's just delete this to yeah, whatever. All right. New system. Let's try omnidirectional burst. Create G test points, something like that. It's been a while since I did anything with the particles. Just gonna see what it looks like. Make it loop. All right, and now that appears to be positionally based. So now if I do this, yeah, it's working. So I would have already caught up to it, but it's still off in the distance. And it works going away from it as well. So the idea being here that like you could generate a point cloud for like a galaxy and you could define like parallax parameters that would befit like something scaled the size of a galaxy. And then you could do one for the universe with galaxies, and that gets different parameters based on like the actual versus the ideal scale. And all that stuff is derived from like some data model stuff that I have in another project. I just am doing this as like a standalone plugin that I can pull in. All right, so um, wow, I think I killed ChatGPT. How can I make a simple Niagara system to represent a cloud of stars? The particles should not die and should be instantiated in their expected locations given desired scale. I've done this in the other project, but um, I'm out of my Google Gemini tickets for today. Oh no, no, I finished it. I can show you that. It's pretty much done. There was like one thing I wasn't able to solve very well, which is that um, it's weird when you're inside a gravity container that is also being affected by another gravity container. I was never able to quite solve that because it has to do with the way it's calculating like there's a flag I have checked on the character model that's like oh god, I'm trying to remember. It's like uh something about
trying to face like the control rotation or something like that. And the if I turn that off, the behavior acts like not the way I want it to. But if I like it causes problems with the aforementioned scenario where like you have a physics zone that is dynamic and moving and like attached to like a platform or something that's inside another gravity zone and is falling. So like it's not going to be usable in its current state for like vehicles that you could walk around in while they're flying, but for everything else it works really good. Um so I kind of just hit the pause button on it because it's like most of the way done, and to get that last little 5% um, is actually a pretty heavy lift. Like there's a lot of additional work to do to get that. So eventually I'll go back to it, but no, it works great if the gravity overlaps. That's fine. It's when the only problem it has is when a gravity zone is attached to a physics enabled object. So like say you have a box with a door in it, like a house or something, and you wanted custom gravity inside that house. So you have your house object. Inside the house, you have a zone, a gravity zone with a high priority that is attached to the root of the house. So it should move with the house. And then say I wanted to drop that house inside of another gravity zone that's a lower priority, but it's going to affect the house itself, but not the stuff inside of the house. So your player model is inside the house, and the house is falling through space in the other gravity zone. But inside the house, you're supposed to be like within that house's frame of reference, getting pulled down onto the floor of the house. But like the character grounding logic that like makes you like stand up because you're like pressed up against the floor, it like starts fucking up. And to fix that, I basically have to rewrite the entire like logic that determines like which way the character is facing, um, based on like gravity and other factors, and also the grounding logic, which is a lot. Just having like two static gravity zones in space that are interacting with each other actually works really good. It's only when one of them is like uh, falling inside the other and you're inside the one that's falling. But yeah, it's a challenge. So let's see what this says. Okay, sure. Negative emitter, emitter, star emitter, one or infinite, doesn't matter. We use burst only, emitter, uncheck everything except what's necessary. A spawn count to however many we want. Okay. Once. Okay. Particle lifetime module. Okay, I don't want this. I don't want this. Don't want this. Don't want this. And initialize particle velocity 0, 0, 0. Okay, initialize particle.
make it bigger. Okay, not too bad. And then, so this is at 1,000, and we're gonna take, okay, here, take it to the 0 location so that it corresponds. Let's take this down a bit. Or maybe not. Maybe we take it up a bit. All right, and we know that we set that to 1,000, so we're gonna set our actual scale here to 1,000, and our virtual scale, let's do 10,000. That's 10 times bigger. And then if I start right here, okay, that didn't work. I don't think it worked. Um, let's make sure. Parallax root 100,000. Yeah, no, that's not working. Okay, so why isn't this? It was just working a second ago, I think. Hmm. Also, let's get rid of this skybox stuff. But yeah, now we're just trying to figure out, because like this is the use case that I want to do here, which is like basically generating a point cloud, and like even though the point cloud is only 1,000 distance from the player, it like moves as if it's like galaxy sized. Um, but this is not inheriting the base motion of the parallax actor, and we can test that. In fact, by just adding like a cube, and we'll call this. We'll give this a collision. Nope, nope, no collision. And now we should have a cube representing the root of our system right here. And if I do this, we can see that it is moving the root the way it's supposed to, but it's just not applying the motion to this. Okay, I have a basic particle system. Looks okay. It is attached to my parallax root actor, which is supposed to handle parallax scrolling motion. However, the system is not moving along with its parent the way I want it to. Do I need to make some change to the particle system so that its particles move when its parent group does? Its parent system does? World space by default. Meta properties, sim target, CPU sim, local space. Okay, great. Easy peasy. So we just go here, emitter state, emitter properties, um, local space. What the fuck is going on here? I don't think this is right. What? What the hell? Okay, maybe it is right. Maybe it is right. Okay, I think it is actually. Yeah. So now I have this particle system, which we can see from out here is not huge. Like this isn't a large object, but when we're inside of it, as our frame of reference, it appears to be large because it's moving along with us. So if we go back out here, we monkey with this, and we just change it to like, oh, it was 100 times, is why it was moving so slow. So like we could actually go back to 10 times. 100, the difference between 100 and 10 is quite substantial. And then I do this, and it does appear that I'm moving through the system just at a rate that's about 10 times slower than what I'm actually moving at. And we can take so all this data is procedurally generated into an octree, and we can figure out what the scale of the level of the octree it is to determine like actual proper calculations for what the parallax factors should be for a given like layer of data. Awesome. So we could do, and now even cooler, we should be okay. So we'll get rid of these now. Now that we have our like point cloud here, so let's duplicate this. Make a second one. Edit, duplicate this. Attach to the second one. We'll have this one go to 2x, and we'll have this one go at 10x. And now, when I'm in the middle of this, yeah. So like I'm moving through one that like this would be like the smaller scale cloud. I'm moving through at a different rate than the larger scale cloud, even though they're literally overlapping in like if I look at it in the scene, like these are just two overlapped copies of the same system. But when I'm inside of it, one is moving at a different rate relative to the player than the other one. And that would be like a difference in scale, right? So like one of these could be like stars in a galaxy as I'm warping, and the other one could be galaxies in the universe. And you move through them at a different scale. And it's going to have to match up with whatever the data model says too. All right. Pretty cool though. So if instead of 10 I just do 4, for example, now we have one that moves 2x and one that moves 4x.
And obviously, these wouldn't be perfect spheres of points. I actually have some point cloud formulas, like I can generate spiral galaxy point clouds and different types of random distributions. Hell yeah. Alright, this is cool. And the cool thing is, so when I was doing this and I was just attempting to jam in like the actual like intergalactic distance scales on these point clouds, things like when you got close to them, they would be jittering because of precision issues. But with this, we shouldn't have any precision issues because the actual objects are in a relatively like high precision portion of the game world. It's just that we're like bullshitting your senses into them feeling larger than they actually are. And then eventually, as a part of this, like I'm starting to work on the basically very large scale movement framework to be able to like go from walking around on the surface of a planet to flying between stars to flying between galaxies to going into a galaxy to going into a star system to landing on the surface of a planet and being able to do all that in like real time without having to do like load screens or anything like that. And to do that, I'm gonna need some origin rebasing logic. So like once the players traveled a certain distance, we need to rebase the origin. Um, that's for like stuff that's in your local space, basically, and also like a way to kind of transition between different movement scales. And that's kind of what I'm hoping this can provide me is like the particle systems provide everything that's bigger than your local like solar system level of objects, and we control like the scrolling through that via this kind of parallax system of motion. Okay, so that's cool. Pretty nifty. Yeah, and like it's all based on Octree. Like the way this works is we generate point clouds in relative space. So I could generate a point cloud in double precision between like -111 and 111. And we can take that point cloud and inject it into an Octree at different depths, depending on how big we want the thing to be. And then that'll be in your data, like you have it in your data. And now um, when you read that from your data, you could say, I'm getting this from depth 17 of an octree that's the size of the universe. That means it, like that octree, like that node space is, should be this size. And that becomes like your parallax scaling factor for any objects found at that layer. Um, it's still a lot to figure out in like mapping between what's in the scene, what's loaded in that you can actually interact with as objects, what's represented in like the particle systems that are like outside air quotes of the scene, and like when and how do I transition between like, oh, I'm getting close to like this star at some point, this has got to fade out, and like an actual star system has to be proceduralized and loaded in its place using like its seed to generate that system. And same thing for like galaxies and things like that. So like that all has to be figured out, but this is like the first step is to kind of get this kind of relativistic scrolling point cloud system in place. It's kind of cool. Kind of cool to just run around through it. But all we need here is actual scale, which could actually literally just be the same for all the point clouds. Like this doesn't have to change. This would be the size of the point cloud. So let's say I'm using this for like galaxy point clouds and universe point clouds. Both those point clouds could be like, 10 billion units or some sufficiently large number to where this ratio doesn't get too small. But then the virtual scale is like the actual size that you want it to be. So like if I want it to be the size of a universe, and it would be like the size of a universe, or if I wanted to be the size of a galaxy, then this would be like the actual size of a galaxy. And then as long as those two things are set accurately to what you're using, the movement should be correct. And then the other thing that we can do is this effect coefficient. Let's say we wanted to move into like hyperspace. Excuse me. So if we wanted to move into like hyperspace for these two, well, maybe I unload everything in my scene and I take this effect coefficient down to like zero point 0.2 for both of these. And now it's actually going to move faster than I'm actually running at. Like this is moving at me faster than I'm actually running. Um, Actually, what the fuck? Did it set for both of these? Zero point 0.2. Let's go even smaller. 0.05. 0.05. And that's really useful because that can give me like a basically single place that I can go to change a speed factor and hopefully have it affect all the all the stuff. Something's not correct here though. As they got smaller, I might be capping it somewhere. Skylight. Okay, we can fix the skylight thing too. Delete this. Shut up. So yeah, I'm not sure about that yet. Go back to a 1 and a 1. But yeah, the idea being that like we have. Yeah, well, I want to do something similar to like Space Engine where you can fly around at different scales and kind of seamlessly transition between them. And this gives us like a warpable number to do that, right? Like the amount of the parallax effect we apply changes the speed that things approach you. I guess maybe that was my initial thought anyway. Hmm. Doesn't seem to be working perfectly right now though. But I did just start on this today, so like there's still I'm sure a lot of work to do. Let me try to. I want to get rid of. That's just gonna have them all at the origin. Yeah, that's not gonna work. They need like random starting positions. Right here, maybe lifetime, position mode, direct set. And how can I randomize the starting position of each?
Oh, it's all good. Faking it for hyperspace is the way that it would work like 99% of the time. It's just like I have a very kind of like specific, unrealistic goal in mind, which is kind of doing what Space Engine does, which is like the seamless transit and like the ability to look at a star in the night sky and like start W keying towards that star and eventually getting there and having it like load in stuff for that star. Um, There we go. Okay, that's what I was looking for. So, and we can just go ahead and like, I don't know, rotate this or some shit. Maybe like give it a 45 and another 45 and one more 45. Just basically rotate it so that it's taking up random different spots. And now, um, I'm pretty sure the parallax route is working. We can go, we'll leave this visible, turn visibility off. Okay. So now if I start here, we have one like local cluster that moves faster and one larger cluster that moves slower. Oops. Okay, and then if I go into our parallax routes and we wanted to do something a little bit more akin to like a actual star field, we'll do 5,000 here and we'll do, I don't know, 20,000. Now I'm going to start in the middle, moving through the slow moving ones, and then over there's that like local cluster. Now we're in the local cluster. Now we're out of it. And it would be like, that's a single galaxy, and these are all galaxies, or something like that. Obviously, the scales are way, 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 way off for that. But that's like the idea. The scale would probably be more like, I don't know. It's even bigger than this, I'm pretty sure, but we all right. I have to do a bit of googling. I had an idea about camera filter as effect for there's definitely some stuff you can do with the camera that will lend a sense of speed. In fact, I think there's a couple games that do this. It mostly involves fucking with the field of view. I think there's some games that literally like their sprint does not make you faster; it just changes the field of view. So if you if you want just like the effect of speed, um, like as you get faster, uh, making the field of view also get larger will cause it to feel like you're going faster even if you're not. Um, but it will also like if you are, it will still make you feel like you're going faster than you actually are. So like I've fucked around with that a little bit where like you would do something like the field of view at maximum speed is 110, and at like minimum speed is 90 or something like that. And then as you kind of throttle through your speed, it will pull the camera back and everything like gets stretched out, and it makes it look like you're going faster. So that's like one way you can do it with the camera effects. Good for like a racing game or things like that, where like sense of speed is really important. The real trick is going to be making these parallax effects so accurate that they will always correspond to the data, so that like I can do checks against the data and say, oh, I'm close to this star here. I need to load in a star system for that. Um, because like now we're talking about going between like a fake coordinate system and a real one. But this is sort of working. It's kind of cool that like you get that effect with just them overlapped. Like when you look at them here, they're just both in exactly the same. If I start up here, it's gonna, yeah. You do have to be careful about the z-axis here, at least for like the test level. Wee. Now let's go ahead and change the kill z. Should be good enough. Or like we get, that's kind of interesting. We get further away very quickly from the. Let's fall through it. Like the other one is already out of range. This one takes much longer than the first one, even though they're starting in the same position to go completely out of range. Kind of interesting. It's cool. It's neat. Oh yeah, it's a that's actually a really great hack. I think I don't remember, it was some shooter game, but it was like they did, they showed the test that like when you hit sprint, you're not actually going any faster. They just like change the field of view by 20 degrees. Um, but yeah, I've done that um, with like the spaceship in another project here. But the field of view change is like very dramatically increases the feel of the sense of speed. It's like, you know how in like F-Zero or stuff like that, like it had a lot of like a really nice sense of speed. It's because the field of view is really wide. So like the things that are on the edges of the screen are going by like much faster, even though like you're moving at the same rate. You're just seeing more shit, so it feels like you're going faster. Yep. Bit of camera shake, maybe like a overlay on the screen to give like some speed lines or speed blurring along the edges of the camera, like a post process effect or something like that, and you're good. It's just like as you approach max, you could say like at 60 miles per hour is the last point at which you have your like default 90-degree field of view. Then from 60 to 140 miles per hour, you're gonna lerp between 90 and 100-degree field of view, and then you're gonna max out at 140 miles per hour, and then like you're gonna have some overlay effects on the screen, like a post process to add like some speed blurring around the edges that intensifies as that speed ramps up as well. And then, like you said, some camera shake, something like that, and you'll have a really nice sense of speed for something like a racing game or something like that. It'll feel like you're going really fast. No, it's just really cool to me that like these are starting in the same place but behaving as if they're not in the same place. I don't know, something about that is really intriguing. Let's try this. Mm, let's crank these scales up a bit. Uh, where's my up here? So let's do 1 to 25, and then let's do 1 to 50. 25,000, 50,000. I approached that faster than I expected. Did I do this wrong? 1,000 to 25,000, 1,000 to 50,000. Oh, derp. Has an effect coefficient on it. So, yeah. So now I'm falling towards it, but it's taking me much longer. I'm gonna have to fall much further. Yeah, so I had the effect coefficient there on one of them, making it go much faster. And we have to fall twice as far to get to this one. There's the mail. Alright, so now if I go back up here, I start in the very middle. Falling through the local system of stars. And then we exit that. Okay, pretty cool. Um, I I have a lot of plans for the background. I want the backgrounds to actually be indicative of what is actually there, which means that everything will be represented eventually in the Octree data models for like the basically gonna have three nested Octree levels. You're gonna have a level for universe scale stuff. That'll be galaxies, big gas clouds, things like that. We'll have a level for each. We'll have a octree for each galaxy, which is like stellar, interstellar scale stuff. So, again, star systems, black holes, gas clouds, and then we'll have one more for like actual local star system scale stuff. Um, I want the background eventually to be a representation of what is actually there in the data model. So, like, if you're looking at a nebula, you could go to that nebula rather than it just being a part of the skybox. So I'm actually not planning on a skybox for this, although I have some. Yeah, yeah. So I have some ideas on how to like. I've made some pretty convincing skyboxes. Like this would be 100 times easier if it was just gonna say like, okay, if it's a star system, we're only gonna simulate at the star system level. Then you could do everything in game space, maybe with a little bit of origin rebasing, and you could just generate a random seeded like skybox for each star system. And when you travel to another star system, like the skybox would have no relationship to like what's actually out there. It'd just be some nice looking proceduralized starbucks, which is definitely a lot easier. But it's not really the challenge that I'm trying to do, which is like having things like if you can see it, you can go to it. Um, that said, at some point, I enjoy the process of doing the procedural skyboxes, and I know a little bit more about it now than the last time I tried. So at some point, I might do it just for fun because I enjoy uh, the process of making the materials for that. But it's not really what I want it to work. I want to do some form of ray marching based on the data model for things like gas clouds and like the different colors and things of sectors. Um, so basically being like each node in the octree, we could say like, okay, we're gonna inject galaxies at this level, and then we're gonna inject like at a slightly deeper level in the tree, gas clouds. And then the way we would display those gas clouds would be procedural, so some kind of ray marching based on that data model. But like, I'm so far away from doing that. At some point, I will do like at some point I will do like because I have the sky atmosphere stuff that I built that has the like really nice cloud ray marching stuff in it. And that cloud ray marching stuff could be adapted pretty easily, I think, into doing like nebula ray marching. But where I'm kind of not sure where to go with it is like, how do I hook that into like an underlying data model? Since it's all like GPU side time things, and that stuff I'm really not certain about. Um, the goal, like I said, is for the skybox to actually be like procedurally generated in a way that like you can look up at a star and like start W keying towards it and like or anything, and like eventually you will get to that thing and it'll load in like its procedural assets for that. um I'm not going to guarantee that like I'm not going to like chicken out and just do like a procedural skybox material at some point because like even here, um even here it would be beneficial and I enjoy making them because I don't know, like I like we can do like the noise based kind of formulaic construction of these things. uh so we got simplex here, we can do radius. Like you've already got some like clouds here, but we can do more with that. We could do like domain warping. Oh, that wasn't very effective. Maybe do it after. Yeah, there we go. And you can do all these kind of cool effects to generate like cool space backgrounds. It's fun. So like coming up with a really cool skybox generator would be another fun little like mini project just to kind of, which I might do at some point, just to kind of revisit something that I have done in the past that I enjoyed, but it's not really my plan for the project going forward. Like eventually I want to do everything you see is real type stuff. What happens if I do this? Do 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 do. Yeah, but like even that, like you already have something that you could use for some like kind of cool nebula background shapes, like a mask. Um, could also change this to gradient, just a gradient. And then you have to come up with like a way to generate stars. I don't remember how I did that, but playing around with just a massive sphere for my background menu. What do you mean by heavy? Like computationally? Or. Then we could take this and do like a background color could be like a deep navy blue, something like this. Then perimeter, maybe like a. And then you have like some nice like kind of background stuff. We can also um, vertex normal times -1. Flip the normal. Make it two-sided. Unlit. And then two-sided. And now you have like a really simple kind of like nebulas and stuff. We could also do things like raise this to a power, change the fall off between these two. And then all you have to do is generate stars, which is not terribly difficult. I just don't remember how I did it. But yeah, so like if I take this and I were to go ahead and add a shape sphere 0, content drawer, apply this to it. And then make it really big like this. Excuse me? The fuck? Yeah, there it goes. And I mean, this is like, you know, 10 minutes. Like, we could do a lot more in depth. But now I have. Oh, oops, it's got collision. Yep. Nope. Nope. Over here, and now we have a little background to go with our scene. Mm. Yeah, you can post links. But yeah, you just like you layer like I would layer more noise in there. But like I want to do it a different way. It's just like I don't know. It's gonna take me a million years to do it the other way. But like this whole project is just for fun and to learn stuff that I'm interested in. So like whereas other people would be like, why would I pursue it that way? That's a million times harder and it's going to take me a million years to get my game done. I'm never going to get my game done. For me, it's like, I'm doing this for fun to learn shit that I'm interested in. Why would I do it the way that I know how to do it that would be easier when I could do it the way that is cool and has a bunch of stuff that I want to learn as a part of it? Uh, Yeah, and like they can get pretty expensive depending on what your shaders are doing. My atmosphere shader is probably the most expensive one I've got, but I'm not sure if there's a good way around it. The like built-in sky atmosphere system is great when you're on the surface of a planet, but it's not super great when you're flying between the planets. Jesus Christ, what the fuck? So right here. So I mean, this looks great. I'm just like I'm trying to figure out what you meant by it's on a sphere. Massive sphere for my background menu. So like, what's the is this like a flat picture of a black hole, or is this like an actual like ray marching shader or something like that? And and what do you mean by just a massive sphere for my background menu? I guess I'm trying to figure out what's going on here, you know? So you have a BP for the black hole, so maybe it is a ray marched. It's all good. The background is a massive sphere black hole. Is okay. So you're using like a black hole shader I had one somewhere, um, but something like because if I remember right, the black hole shader I had was really expensive. So something like, ooh, that's nice. But yeah, something like this. It's pretty clean actually. Wait, somebody has a. This is like a lot less code than I would have expected. Wow. So he's done this with just this, huh? And some. It's pretty cool. Of course, there's a seam here. Yeah, have you ever messed around with Shader Toy? It's a really useful resource. So like, this is all GLSL, and Unreal uses HLSL, but like going between the two is not that difficult. So I've definitely taken stuff from here and like converted it. Oh, that's a nice one. And converted it to like shaders in Unreal Engine. Because like it's just you just have to know like Vec 2 goes to Float 2, Vec 3 goes to Float 3, that kind of shit. And then you can do it in a shader in a custom node. Okay, yeah, that's cool. Um, so you've got some volumetric nebulas in here, or is that just a skybox? I'm not sure. It was hard to tell. Pretty neat. Just a skybox? Okay, I gotcha. Um, yeah, so yeah, well, and like if I remember right, the black hole um HLSL is pretty heavy duty. Like for something like a menu, you might be able to get away with just like a billboard or something, and that would speed it up quite a bit. Or yeah, I mean, like if you control the camera angle for it and it's just for a menu, then having it be like a fully calculated uh, HLSL like black hole may be overkill. Like you may be able to get away with like faking it, but if it's something that you want to have as like a game element that you can like fly around and shit, then yeah, you need some way to render it. Although some of these, I mean, like maybe check some of these on Shader Toy because like one of those is only 600 characters. I've like when I did my atmosphere cloud shader, I used a lot of stuff from here, and I think that one came out really good. Like here we can look at that. Yeah, it's a great website for like shader code. You can get examples of a bunch of different really nice shader code stuff. And a lot of times it'll be like really well segregated into like, here's how to do this explicit thing that you're looking for. And it's all in GLSL. So like that's a pain. But it can all be converted to HLSL without too much work. Definitely easier than writing it from scratch. Yeah, so it's like that's a great resource for shader coding. Um, I use it pretty frequently. All right, so this has got to compile shaders, but I'll show you the sky atmosphere I have. It's no okay, so it's um it's HLSL, which is not C++. It's a shader language. It's kind of similar to C. Like I don't know. I've been coding for so long in so many different languages that like they're all kind of just the same to me. It's like whatever. Okay, so what do I call a float here? Oh, it's not a float. It's a double here. Okay. What do I call a vector? Well, over in GLSL, it's a vec3, but in HLSL, it's a float3. Like that kind of stuff is the difference. Um, so if you go into Unreal Engine and you go into a material, you can make a node called custom, and this node is actually defined by the code here, and this code is HLSL. So, and there's a few kind of caveats to using this that make it more of a pain than just doing it on like a shader toy thing. One of the big ones is that uh, you can't make your own individual functions unless you enclose them in a struct. So usually what I'll do, VS Code, I'll pull one up. So usually what I do is but this allows you to use shader code directly in Unreal Engine um, materials. Let me see here. Here we go. So for example, here's my atmosphere shader. So it defines a bunch of stuff. So like, what I mean by wrapping it with a struct is like you can define a struct here that is my cloud atmosphere function struct, and that wraps all my like helper functions and ray marching stuff, um, 3D noise texture sampling stuff, and then finally at the very bottom, I close the struct, and then this is the code that's actually getting like executed in the shader. So we define a copy of the struct. I set all my values, like my input parameters for the struct. And then finally, we just invoke on that struct the main image function, which is right here, which basically invokes calculating atmospheric scattering for the atmosphere, as well as cloud accumulation for the cloud data, and then composites them together and exports the results as a float 4. And then once this loads, I can show you what the material harnessing that looks like. But basically, I mean, it's about to load. Um, but like this is a way that you can do like really powerful stuff via materials that you couldn't do otherwise. Like ray marching is a big one. If you want to do like custom volumetric stuff, you can do it. Oh, it's a lot of fun though. You'll enjoy it. This is a super fun rabbit hole to go down. Shader coding is like one of my favorite things now. Like I just really love it. It's a simpler language than C++, but it's all math pretty much. So it's kind of whatever. Like, all right, 70 shaders left. But I'll show you why I wanted to build this once this project loads. Mainly, it's because the built-in sky atmosphere does not work very well when you're transitioning from like space to ground. Like there's some really weird behavior it exhibits with cloud display and with like switching between the outside the atmosphere view and the inside the atmosphere view. It doesn't work super great. So the one I've got here is fully volumetric clouds. We can we have control over what the clouds look like. Like we can change the way our noise is composited to make different clouds if we wanted to. It's all volumetric and it has like a good transition from space to ground, which it should load up any second here. But like the whole shader coding stuff is a lot of fun. All right, am I gonna get it open? Here we go. Okay, so here we go. You can see the cloud atmosphere shader running here on the outside of the planet. We have things like if I go behind it, we get like the halo effects, right? We also get like the atmospheric scattering effects and things like that. And then if I go down through it, it kind of takes over the sky. And then since I'm close to the night side, I'm getting like sunset colors. But if I go closer to like the day side over here, I'm getting blue sky colors. If I go like right on the fringe, you can kind of see the light shining through the clouds, the sunset color. And another cool thing about this is because this is all entirely on a shader, if, say, we wanted to proceduralize our atmosphere, I actually already have this one implemented fully. So, like, if I change the seed here, it would change the sky we get, the atmosphere entirely, and it can change it between, like, preset ranges of different acceptable colors and configurations. So, like, just well, it's not affecting the clouds right now, though. I don't know why my clouds aren't changing. But yeah, and also like sunset colors are all derivative of the primary atmosphere color. So like if you have a pink atmosphere, your sunsets will be one color. If you have a green atmosphere, it'll be a different color, et cetera, so on and so forth. I think I'm having issues because like right now I was doing experiments with like very large planets. So like I'm actually really far from the origin here because this planet is like much larger than an actual real life planet. This is like a uh, 10 times larger than Jupiter planet here. So like I'm getting artifacts I think from precision, but yeah, and this is all just a shader. Yeah, and so like it's cool because now I have this thing, and now if you fly into like you get the smooth like sky to ground transition. Um, you get the ability to just, oh, I want a different planet. Oh, I want a different planet. Oh, I want a different planet. You know, like just a different number, and you got a different planet. Like here we go. We can see that this atmosphere is pink. So if the atmosphere itself is scattering like a pink color, then we would absorb pink from the atmosphere, and so our sunset color is like a teal green. Whereas if we were on like a blue sky, it would be closer to like earth colors. And it's all just automatically derived from the uh, the randomized parameters. And like I have a whole system for that too. Like we can define all our randomization parameters here, and it will randomize between them. Um, Basically, you figure out like here's a struct and it's going to define how my clouds look. Every factor that goes into this material that controls clouds will be in this struct. Here's a struct and it's going to define how my atmosphere look. Every parameter that defines how the atmosphere looks is going to go into this struct. And then after you have those two, you make two more structs. they're exactly the same, except instead of having one value for each of those inputs, they have a range of values for each of those inputs. And then finally, you create a harness to take those values, those like bounded structs, randomize all the values within the provided ranges, output the struct that actually controls the appearance, and then feed that to the material. And that's how the like seed-based parameterization here looks. But if we go here, maybe, um, we should be able to construction script. Yeah, here it is. This creates because of this initialize. And this is basically just setting a bunch of material parameters in here. But I really wanted to look at, okay, it's empty cloud atmosphere. That's what I was looking for. So, empty cloud, damn it, content drawer, empty cloud atmosphere, HLSL. I think it's this guy. Okay, and the way this works is so that that code that I just showed you in Visual Studio Code is in this custom node. You can define a bunch of inputs into it, which these are what are coming from those structs I was talking about. So like these are all the parameters that go into this function call. Um, at the start, it basically takes all those parameters that are inputs to this and maps them to the actual cloud atmosphere function structs internal values, and then finally calls the main image once that's done. But this really is basically it has a bunch of inputs that map to parameters that go into this HLSL code. And then finally, the output of this is just plugged into emissive color in a post process. And then I just run this in a post process object without a bound on it. So, like an unbounded and a post process thing. And then, of course, like the planet is a whole nother can of worms, but it's the whole like quadtree based asynchronous mesh generation stuff that I spent a lot of time on. But like right now, this is so big. Like, I think the planet is. So let's figure this out. So our planet right now is okay. This many meters. So our planet is 64,000 kilometers in radius. About 64,000 kilometers in radius. Radius of Jupiter. Okay. So it's almost the same size as Jupiter. And I made it that big because I was yeah, it's a ton. It's a ton of inputs, but like you understand like when you write it, like you understand what they do, and like you don't have to fine tune the inputs. You just like define ranges that they get randomized between, and then you just let the proceduralization take care of it. But yeah, the so this planet is about the same size as Jupiter right now, and I was doing that because I was testing. At one point, I could only get it to have precision up to about like 200-kilometer radius or something like that, but I changed the way I was generating the mesh patches in the planet to instead of generating the mesh patches at the position they were going to occupy, I generate the mesh patches at 0, 0, 0, and then I move the entire patch out to the position that it's going to occupy, which fixed like the precision issues at lower scales. So this was like uh, when I left off, this was like me testing it at very, very large scales and making sure that it could still manage. Oh, did I crash? Might have crashed. Yeah. It's not perfect. But like all of these things are just like little bits and pieces of the end goal of like trying to make something kind of like Space Engine where you can go down to the surface of a planet, blast off, look at a star in the sky, gas it towards that star, eventually get there, land on a planet on that star in that star system. Um, there's other cool stuff in here, but the parallax stuff was kind of I spun the I another thing I've been trying to do is break the uh I don't generate it yet, but I would just use the PCG system for that, I think, because I've seen other people do it with the runtime mesh generated mesh data. So what I would probably do for foliage and like ground clutter and stuff would be create a whole nother material that controls that stuff, and then proceduralize it somehow with the PCG system, the mesh data, and the material. Some conjunction of those three things to do like biome foliage areas and things like that. But I kind of stopped on that and started looking at gravity because that became a blocker. Yeah, it's another massive rabbit hole, exactly. And I want to do something that's like really really big scale, and so I don't want to get too bogged down on like the planet scale stuff yet until I've worked out like the interstellar and intergalactic motion and visualization stuff. Because whatever I do for foliage, I want to make sure it works with that. Another thing I've been trying to do is break down the like component parts into their own individual plugins so they're a little bit easier to maintain. So like eventually I want to get all of this planet generation stuff. I'll probably make a plugin for the atmosphere. I'll probably make a plugin for the planet generation. Um, right now I'm working on like the parallax movement plugin to apply to like the star systems and things like that. I have the gravity plugin. So yeah, just like kind of breaking them all down into sub projects and then eventually combining them back together. I also have a little data structure plugin I wrote, but I wrote it in stupidly in 5.5 and all my other shit's in 5.4. So I'm gonna basically need to refactor that into a 5.4 plugin to use it. But it has my Octree data models that are like the. I have some Octrees I wrote where internally the Octree uses an int long coordinate system. Yeah, yeah. It's like right now my planet is just a fucking empty plane, and like this isn't so much a game as like a exploration of stuff that I'm interested in. So I don't necessarily care if it's ever interesting because it's interesting to me to just like code all this stuff. But yeah, for sure. With things like, I mean, even like No Man's Sky now was probably the best in class, and even that is still like kind of samey. There's like one thing that I thought would be really interesting is harnessing like generative AI to do population and generation of procedural assets. I think that's an area that would be that's kind of like unexplored, but would be really cool to fuck around with. So like instead of instead of having like a preset like kind of Lego based system of different animal and plant models that just kind of get remixed together to produce diversity. You like literally have an AI generating like models on the fly in the background. That would be interesting because we know the AI like there's yeah, because we know that AI can generate like 3D models and stuff. So what if like it got good enough to where you could say like you have your prompts themselves generated procedurally from your code. So like maybe your prompt structure is like in X star system, Y planet exists. Here's like a high level description of the planet. It's temperate, it's swampy, it's mostly water. Some like high level stuff that can be derived from like your proceduralized assets, and that forms a prompt. and it says generate, 40 different life forms for that planet and their models and animations and all that shit, and then it does that in the background, and then like now you're populated with something that's like truly unique, not just like remixed like bits and pieces. But like I don't think the text there yet, but like that's kind of what I view as like the holy grail of all this generative AI stuff is eventually you're gonna sit down, you're gonna be like, you know, I really feel like watching a humorous sitcom today, something like a blend between Always Sunny in Philadelphia and Friends, and like you just get a TV show. It's just like here's your TV show, and you just watch it. It's like oh yeah, that's what this is. Oh, there's yeah. I mean, it's gonna be disruptive. It's already disruptive. It's just gonna get more disruptive as the time goes on. It is what it is. My kind of philosophy is that like that shit's scary, but like I've always been the type of person that says, okay, if things are changing, I want to understand and like have control over whatever's causing that change, and I want to learn about it and figure it out, rather than like I'm not gonna do that because I don't like it. It's like I don't like it, but like it's fucking reality now, so I better get used to it. That's kind of the way I look at it. Because in like 20 years, all the drama right now and the things that people are upset about right now with AI will be completely different. And like, yeah, that kind of stuff. And like, you've already got image generation as well, right? So you could easily like daisy chain that. Like, AI number one, generate a description of an alien creature for my planet. AI number two, generate an image from this description that I just got of this alien creature on my planet. AI number three, generate a 3D model from this image of an alien creature. Like that kind of daisy chaining has potential, especially in a game that's like procedurally generated with like where you want there to be like weird ass fucking shit popping up every now and then, and you don't necessarily care if the life forms are always like logically make sense. This is super cool. I actually really like this parallax thing. It's very nifty. I want to like I need to make a I need to make a pawn that just works like the preview pawn and can have the speed like basically arbitrarily set so that I can get like all my begin play stuff in like a simulate mode type pawn. Because I'm gonna want to be like flying around for these things as I go a little bit further. Because like next up with this is I need to basically. I think this as a plugin is literally just the parallax root. I don't think it needs anything else. But I need to start working to make this work from the data model, like generate the because like I already have a data model that'll generate a universe of galaxies, and any one of those galaxies can generate its stars. I have that already. I mean, like I already use it for solo dev for like bouncing out. Like to me, the best usage of it has been like there's not really a lot of people you can talk to about the stuff that are gonna know what the fuck you're talking about because it's all very like arcane, archaic stuff that like not a lot of people ain't nobody got time for that. You know what I'm saying? So like you can bounce ideas off of it and have a record of those conversations, and go back over it, go back over your old ideas, figure out if they make sense or not. It gives you like input on potential other methods that other people have used, and having a record of all that is really really nice. Having that rubber duck to bounce ideas off of is really really useful. Generating code is more hit and miss. Like it depends on how complex the thing you're doing is, I guess. How common done it is. If something's done really commonly, it'll probably be fine. If it's something more complicated, it's almost never right, but it'll get you like 70% there. And then you just have to figure out what's wrong with it. But like if you're not able to look at it and understand what's wrong with it's hopeless. You'll be completely fucked, and you'll probably go too far too fast without understanding how any of it works, and you won't be able to ever debug it again when it inevitably breaks. Because like the bigger the system, the bigger the number of interlocking parts, at least for current AIs, the more the inaccuracy rate goes up. So for like a single class or a single function, it's usually pretty good. But as soon as you're talking about like the interplay of a bunch of different systems that are all complicated, it's like it quickly gets worse. But like it would be naive to think that it's going to be like that forever. Um, Shit improves a lot, so yeah, it's scary, but like, what are you gonna do? You gotta fucking roll with the punches. I'm not gonna not use it if it's clearly providing me some kind of performance improvement. Let's see. So I don't know what else to do here. I guess okay. So let's make a pawn. Um, Actually, that's what I'll ask. Coworker. Okay. Next, I want to create a new character class that has similar controls to the editor simulation mode camera and speed control. Uh, so not affected by full 3D movement controllable speed. Floating pawn. Yeah, the it's like I don't know, man. It's gonna fuck with a lot of status quo in good and bad ways. And it does suck that it hits like artists and stuff. I think there will always be some degree of value in like, oh, you're a band, I can go see your show, and I can give you like $100 at the door to go into your show, and like, I don't think that's gonna be something that you would do for an AI. Like, why would you? Like, what's the guy gonna do? Go up on screen with his fucking laptop and Suno pulled up and plug it into the sound system? Like, so, but like, and then like, for as long as the, I guess, ethical objections to art persist, then there's always going to be a market for it. But like, I don't know how long businesses are going to fucking do that. I don't trust them to do it for any longer than it takes. Yeah, maybe. Okay, so floating pond. So can I just do that? Can I just add a floating pond? Let me see. Edit. Where's my settings? All right, so am I just a floating pond now? No, hang on. There we go. Okay. Okay, so that's our spectator pawn. This stuff should be working now. Hang on a sec. Bed jumping. Figure out what's going on with that. Yeah, this even has, I think it has a little bit of a POV switch between moving and not moving on the spectator pawn. It's like that little like zoomed and spring back when I let it go. I think that's the FOV lerping. These are much further apart. Okay, so now we have a flying pawn. So that's cool because now what we can do is change this to like 100 and this to like 5,000. And now if I start in the middle, we should quickly escape the smaller cluster, but the big cluster should be really big. So we're in the middle of both. I get out of the smaller cluster, which is right there. And now I'm traveling among the larger clusters. And like if I wanted to go to this guy, I could go to this guy, but then he's not like jittering. What is this springiness? The springiness is getting me like it's I wanted to be precise, damn it. I guess that's what I get for using like the default pawn. But yeah, there's our cluster. That's pretty cool. So it's cool that these are the same particle system. I mean, not exactly, but like they're the same size, which is cool if you think about it. This is this is actually easier to do than I thought it would be, too. So like technically, if we spawn in right in the middle, their like position should remain the same relative to each other. So like there's this cluster, it would always be there inside this larger structure. Like if I went over here to this and I came back, it's still going to be in the same place in the relative overall system. Need a way to test it. I don't know what this springy. There's like a springy, like when you let. There's some kind of springy motion attached to the camera arm. Yeah, that's like I just threw it on there, but like having the spectator pawn is good too. And then uh we need a way to set the speed. So we would just like override the spectator pawn. No, delete. All classes. Now we can just add. We just add a speed variable, movement components. Now we move substantially faster. Hell, that space spectator pawn, that's really fucking useful actually. I've always like just to have the like player camera and not it like so in my C++, you can check against the viewport camera, but in Blueprint you can't. So having the ability to just spawn this little shitty pawn that can fly around and no physics or anything for testing purposes is really nice. Okay. Speed. Floating pawn movement. Max speed. I wonder if I can change the fucking camera behavior. That like springiness. I said the floating pawn movement? Yeah, there it is. Something like that. Now, so it should be much faster again. These little motions, I gotta be sure that those are not a part of the. I think it's because the camera's on like a swing arm or something. Maybe not, though. Basically, like, okay, so I'm doing like WASD, WASD, WASD in a circle, and something fishy is going on here. Like, it does move, but it's probably just part of this movement component. I don't know if I care enough about it to try and figure it out, and maybe just wait until I build the spaceship component again and try that. So these are the ones on the big one. So hang on. What if So now this one. 10,000. 50,000. Not bouncing around as much. Okay. I think that bounce around is when you. It may be due to, like. I'm not actually sure. Actually, now that I'm thinking about it, I'm not certain. But this does seem to be working. Where's my cluster, though? Am I even out of the cluster? It's a pretty nice effect, though. And, like, each one of these points is visitable. I need to add to this controller, I need to add, like, mouse wheel up, down, increase speed. Yeah, this close you would have wanted to swap this out already for, like, the star system or whatever, but and then we could go into, for example, our this um, sprite renderer default sprite material. We can do just thinking. I kind of want to thinking. My goodness, Jinx. So like, I want to make these brighter, and I want to randomize this. Let's just make them brighter for now. Let's do. out on me. Oh, you son of a bitch. Alright, make it a little bit brighter. What else can we do? We can go ahead and tools. Actually, bounds, infinite extent. Send you to the origin and um, enable infinite. Um, there we go. Okay, a little bit better. Fuck, what is it? Can't remember the name for it. Shit. The um, there's a setting I need to change for in this, and I can't remember. Um, exposure. I don't think that was it, but it was like, where is this lens? I'm at the dead center. Start this up. Do a drive by. But eventually I should get out of this cluster. And then what if, and we gave this one like very, very, very big. Right, so now need to increase the speed of the pawn. Go to 0. We start it up. Or is this a big one? I think that's a big one. And then the ones that are far away are just like almost unreachable. Like I'm leaving the second cluster here. That's pretty cool actually. But those are all actually the same size. Pretty neat. It's crazy. So this is only 10,000 units. Where why is this not going much faster than I thought it should be? Where was he? This. Let me see here. Where is my 0? There it is. We're basically at 0 here. Those three stars are really far away. They're in the like big field. Found them again, navigating by the stars here. Need to add mouse wheel speed up, speed down to this. The bindings for this controller. On some kind of like logarithmic scale. Alright, we're now completely out of both the like lower order point clouds. They're back this way. And we're just in. If we face this way, we're just in the like large scale. It takes a long time to get anywhere. But we are moving. The cool thing about this is that we can represent this motion at like lower speed scales too. So like no, it doesn't use nanite. It's static mesh. It generates it uses real-time mesh library and generates a bunch of little procedural mesh patches. And then it just subdivides with the quad tree basically. So if it goes, it'll go down to like some predetermined level of depth of detail and then stop. So as long as the camera starts around 0 here, and then like the star position and all the position of these stars would be actually generated procedurally in a data model, not just a random point cloud. But what are you looking at me for, dude? Sitting here looking at me. Oh, you know what? He wants his wet food. All right, I'm gonna feed him. I'll be right back. Feed this pup. All right, I'll get you lunch. You're right. I forgot. He was looking at me like, Dad, what the fuck? All right, all right, all right. I'm also not even sure if that's gonna be the planet generator I use because I might try something with voxels too. I have
like almost all the way done voxel generation uh, plugin. That's the one that has all my data models and stuff in it. Needs to get reverse engineered to go to 5.4, but it's useful. Actually, I think I'm at a pretty good stopping point here. I think I'm gonna play some Magic. So later.